Hello everyone. Today we are going to talk about dimensional analysis. Now what is dimensional analysis? In physics we have units. All units have their own dimensions. For example, length has a unit of SI unit of meter. Mass has a unit of kilograms. Time has a unit of seconds. Now there are other units like speed. Speed is not a fundamental unit. Speed is a secondary unit. Speed is nothing but length per time. So its unit is meter per second. Now these are units These are fundamental quantities and their units. But what are dimensions? What's a dimension? What's a dimension? Dimension of length is L. Dimension of mass is capital M. Dimension of time is capital T. What does this mean? Dimensional analysis just means if you have some quantity, what dimensions are gonna be in it. For example, if you take speed, as you know, speed's unit is meter per second. But what are its dimensions? Its dimensions are length per time. Its SI unit is meter per second. Its dimensions are length per time. That is capital L per capital T. You know what's acceleration? Acceleration is nothing but meter per second square. What are its dimensions? Length per time square. This is not to be confused with -1 and -2. -1 and -2 are its power. So this is nothing but capital L by capital T. But we do not write it as capital L by capital T. We just write it as t to the power -1. I hope you understand powers and now suppose you have a quantity x and suppose you know it has a dimensions of L. What do you think it is? It's nothing but length. So with the help of dimensions you can predict what the quantity is. For example, Suppose you know a quantity x that varies with time inversely proportionally. That means you only know that as time increases, the quantity x decreases. Then you are given another info that your quantity x is directly proportional to length. That is, as the distance increases, your quantity x increases. So what will happen is, through dimensional analysis, you can write the dimensions of x as L t to the power minus 1. So just by knowing its dimensions, you can predict what the quantity is. Now here, your x is nothing but speed. Now what's the real use of dimensions? The real use of dimension is, I'll tell you. Suppose you have force F. If you know Newton's formulas, you know F is equal to ma. F is equal to mass into acceleration. Now, what's mass? Mass is kilograms. What's mass? Mass is m. What's acceleration? Acceleration is length time to the power minus 2. Now, because you know this, you can also define force as F is equal to mv by t or delta mv by t. That is nothing but change in impulse per time. So what you can do is, just by knowing the dimensions of a quantity, you can define it differently. You can also define F as mx by t square, where x is the distance and t is time. M is mass. So just by knowing the dimensions, you can define a single quantity in 3, 4, 5 or how many ever ways you want. But what remains is, for a single quantity, its dimensions remain the same. Another use of dimensions is, you can predict the units. Now suppose you take work W. I don't know what's the unit of work, but I just know W equal to Fx, force into displacement. Now I don't know the unit of W, but I know the unit of X. I don't know the unit of F. So what I'll do, I'll write it as F equal to ma, F equal to max. So now I know the unit of mass, I know the unit of acceleration, I know the unit of x. So let's write its dimensional formula. Dimensional formula is m L t to the power minus 2 times L. This we can rewrite it as m L square t to the power minus 2. So what's the unit of work? The unit of work is kg meter square per second square. This is how you can use dimensions to predict units. Similarly, what's the unit of power? You may have heard a joke. What's the unit of power? Unit of power is watt. Watt is nothing but joules per second. It may be joules per second, but I don't know what's the exact unit of it. I don't know what is joule, I don't know what's second. You may have heard joule is a unit of energy. So this is nothing but energy per second. That is nothing but work per second. So this is nothing but Fx per second. That is nothing but max per second. So what are its dimensions? M, L, t to the power minus 2, L, t to the power minus 1. So if we combine it, it's nothing but m L square t to the power minus 3. So the dimension of power is m L square t to the power minus 3. So its unit is kg meter square per second cube. So I did not know what the unit of power was. I did not know what the unit of energy was. I did not know what the unit of work was. I did not know what the unit of force was. But I knew what the unit of mass, acceleration and distance were. And by that I found the unit of power and I found the dimension of power. So you can interchange. If you know the unit of power, you can easily find out the dimensions of power too. You can easily interchange and you can find each other vice versa. Now, similarly, what's the unit of pressure? I know pressure is force per area. Force per area, that is nothing but mass times acceleration divided by length square. That is nothing but m L t to the power minus 2 L to the power minus 2. So that is nothing but m L to the power minus 1 t to the power minus 2. So the units of pressure are kg per meter per second square. Now you might have observed I have written boxes for some of the things and I haven't written for boxes for some of the dimensions. Actually you should write boxes for everything. It's a convention and you should follow conventions. But if you just want to find out units, you can just write dimensions without boxes to shortcut time.